Hello there everyone, UXW Bill here with you today on this absolutely beautiful late spring, early summer day. It's definitely kind of windy out here though. Probably putting Sony's wind noise reduction functionality to the test once again. But since it is such a beautiful day, I'm going to tackle a project that's been on the burner for a while. This is my mother's 2002 Buick Park Avenue, very nice car, also known as Ruby. Ruby recently had a lot of work done on its suspension. But there's another problem that's been bugging this car for a while. It involves the electronic climate controls. You go ahead and climb in here outside of the wind and we'll have a look at what's going on. This is a very common problem with these cars. I was clued into this issue and it's caused by fellow YouTube user Moldy Mac. He mentions that bad solder joints are oftentimes the cause of a blank or nearly blank or unevenly bright display on these cars. Now they certainly aren't the only possibility. You could have a vacuum fluorescent display that's defective or up to air or something along those lines. And of course vacuum fluorescent displays, being as they're basically a glorified light bulb, also do burn out. But that should take a very, very long time before it happens. So let's go ahead and turn the car on here. Hopefully the battery's still up. My mother hasn't driven this car in about a week because she hasn't been here. She's been on vacation in California, and as luck would have it, it's not going to let me down. Go ahead and turn that off so it doesn't kill the battery. You can see that the display is most definitely completely blank, and if we rap on it a little bit, we might get it to light up, but it doesn't look like that's going to happen. You can take a closer look at the display thanks to the wonders of Night Shot. Can see what's in there. I'm not aware of any unused characters in this particular display, although there certainly are some in the radio for optional features that this particular car doesn't have, like the compact disc changer and stuff like that. But again, I'm getting a bit off the subject here. In order to get this out, it didn't seem like it would be too hard. But the one thing I couldn't find any good source of instructions on, short of probably looking it up in the GM service manual or even going to a dealership and asking for a printout of the relevant information, was a guide as to how to take the dash trim off so that I could actually get to this module, remove it, and attempt to service it. I did some web searches and stuff and nothing ever came up. So the first thing I'm going to do is I'm going to tell you how to do this in case you need to service the climate controls on your 2002 Buick Park Avenue. This is all pretty easy, but of course you do want to be careful. General Motors quality being what it oftentimes is, some of these parts are a bit fragile and you might break them. The first thing that you need to do is you need to remove this fake wood trim piece. This has been sitting in the sun for just a few minutes now and already it's almost hot enough to give you a second-degree burn. Doing this is pretty easy. I'm sure there's some people that'll yell at me for not actually demonstrating this on video, but guess what? Tough toenails. I'm telling you how to do it, and if you can follow directions, I'm sure you'll manage just fine. You want to start right here at the edge and use some sort of a flat tool of some kind. My particular tool of choice was the ubiquitous kitchen knife. Yes, indeed. These things are great for everything. No toolbox should ever be without one. You kind of work this loose over here, pull up on it like that, and pop that edge free, being mindful of the wiring connector for the passenger side climate control, if your car actually has that. This was already broken. I did not do this. I'm certain of that from having pried this up slightly in times past to take a look at it. You want to pry up here because there's a little clip that holds it into place. You can see that on the other side there. And then you go down the line a little bit to the next one of these clips. And then you move on. And this is where things start to get a little bit involved because this plastic piece that we're talking about removing right now is actually dovetailed into this one for a smoother looking fit and finish. So you do have to play with this just a little bit to get it loose. And again, if your car has the heated seat option and the passenger side heated seat in particular, want to be mindful of the wiring connector. All these connectors, they either have a tab on the end of them that lets you pop them loose, or in the case of the passenger side climate control connector, as you see over here, they actually have a little tab that you can operate with your fingers to release the connector from its mating plug in the passenger side climate control unit. And then you continue across here until you get to the driver's side heated seat control. And again, you do want to be careful with this because these two plastic pieces do interlock with one another. And you just gradually work this out from around the steering column, being careful again not to apply undue force to any part of this assembly. And once you have done all that, you're just about ready to go ahead and remove the climate controls from the vehicle. It looks to me like there are only 2 bolts, and they have nut style heads on them. No screwdriver slot in either one of them, so you'll have to have a nut driver handy of the appropriate size to remove the climate controls. Now when you remove the climate controls from the car, you might want to choose to be extra cautious and disconnect the battery, but in this case I'm just going to turn the key off, take it out of the socket, and take it out of the ignition, I'm sorry, and that should be sufficient to do the job, at least for my own concerns about the matter. Much more important is to be careful with this module with regards to electrostatic discharge, because this module contains a tiny microcontroller and other electrostatic discharge sensitive parts, so do take care not to zap it with static electricity. We'll go into the real toolbox here if I can actually get it open and get it to stay open without spilling tools all over the car, which might be a trick. And we'll see if I can figure out just what size those fasteners might be. Well, that's too big. I may not be able to use this little twin-handled screwdriver thing. That would be kind of nice though, because it's right there on top and I don't have to go digging through all the treasures in here. I don't know what size. I should probably know what size these are, but I'm not confident enough to say on video and make myself look like a big dum-dum. Whatever size they are, it's not quite the size that holds these in, so I'm going to have to look for a proper nut driver. And of course it does not help matters that my nut drivers, by and large, have the same color handles on them as my Phillips and bladed screwdrivers. Alright, that's 6mm, that's too small, I'm pretty sure of that. That's 10mm. I don't know if it's English or metric, probably metric if I had to guess. I can't actually tell what that one is, so I'm going to shut the video off and find the appropriate nut driver, and I will be right back. Alright, I'm back. I had to go into the garage over there and find a more competent and complete set of tools than the one I had. This toolbox that I carry with me all the time, that I keep for myself, is predominantly related to computer twiddling tools, so my selection of nut drivers is, well, in a word, completely pathetic. Now before I go ahead and remove this climate control head, I do want to touch some more on the process of removing the various dash plastics. You will have to loosen this one up. You don't have to remove it completely. Again, it's just a press fit. Be careful with it. Don't get too rambunctious when you pull it out. If you do want to remove it entirely, the way to do this would be to park the car on a level surface, block the wheels so it can't possibly roll. Go ahead and set the emergency brake if yours actually works. The one on this car does, but it seemed like a lot of bother. Turn the ignition switch to the on position, pull the shifter all the way down into first gear, and lower the steering wheel as much as you can with the provided tilt mechanism. But be very careful if you decide to go that far, because it would not be the first time when working on a vehicle with a tilt steering column, especially a General Motors vehicle, where I've had the dash plastic budge into the tilt column adjust lever, cause it to go flying up. And if you've got your nose right in there watching the process very closely, as you might decide to do, well, it'll pop you right in the nose, and that really smarts. So you don't want to do that. I didn't feel the need to go quite that far. So go ahead and remove the two bolts holding this in, and because I don't want to lose them in the nether regions of the car, I'm going to set the camera down because this one is starting to get loose right now. It looks like my nice day that I was gloating about a moment ago might be getting ready to come to an end. I guess that big strong breeze that we've had all day finally caused a storm to blow in. Fortunately, I'm just about to the point where I'm ready to effect the repair. With a little bit of bloodshed, I got the control module out of the car. The hardest part of this, by far and away, was dealing with this wiring harness. As it is in the original configuration, it just barely has enough room that you can hardly even see it, much less get your hands on it. There's this little locking thing up top, and while I don't imagine that it's strictly necessary to remove it, your little kitchen knife or some other gentle prying tool can take that off. But the business end of this connector is on the bottom side. This off-white colored piece of plastic is actually the retaining clip that serves to hold everything in place. Then you get the climate control out. You can see it's quite an interesting little unit there. The one in the Keykeeper's Bonneville was a bit different than this, surprisingly enough. You can see very little of the electronics inside. There's the piezo squeaker can that makes this thing beep whenever buttons are pushed. And there's two small nuts, one at each side of this casing, that we'll need to remove in order to get it apart. Of course, this plastic is brittle, so be careful with it, whatever you may do. And here, my computer twiddling tools do come in handy. This particular little nut driver is used for re-securing those knurled style nuts that you find on the sides of computer ports like parallel ports and VGA connectors, DVI ports, stuff like that, serial ports, you know, ports that real computers still happen to have. But even weenie modern computers can oftentimes benefit from the use of this tool, and as luck would have it, they are exactly the same size. This is a 3/16 inch nut driver, the finest that Ace Hardware makes, I'm sure. Now for the actual repair. I've gone ahead and brought the module into the house here. Went ahead and removed these two screws that hold the two halves together. Carefully released the surviving clips, and with a little bit of care, I was able to pivot the display down. Now for the diagnosis. It was my understanding that the typical failure with these modules involved these surface-mounted resistors. There are quite a few of them scattered across the board here. There's a couple of them here. You can see they actually have the resistance values printed on them. And there's a couple more over here, tiny little transistor there, a couple more tiny transistors, the solder joints for the vacuum fluorescent display panel. And you can see that General Motors' pick and assembly machinery was not the most precise. This one's a little off angle. There's a couple others that leave a little bit to the imagination, but they all appear to be very firmly attached to the board. Now, finding bad solder joints can certainly be an exercise in and of itself. And if you're ever tasked with something like that, I highly recommend a bright light, a good magnifying glass, and being willing to flex the circuit board slightly, because bad solder joints do not always make themselves readily apparent. So all this seems to check out. With that said about bad solder joints, I found the problem. Oh yes, I did. There are two circuit boards that are part of this assembly. This is the display board up here, and then in here we have the interface and the beeper board. Everything over here on this interface board is through-hole soldered, and there's a whole bank of resistors right here at the front side of the board facing the control panel. And as you can see, they have been sinking a lot of power since that car was manufactured sometime in 2002. And in that time, guess what? They've managed to work themselves loose. Each and every last one of them. It's no wonder the display in this thing was unreliable. What's even more of a wonder is the fact that it worked at all. And those solder joints kind of have an unhealthy gray pasty color to them, so they probably weren't very well done from the factory. I would imagine this board, the display board, being surface soldered, was probably machine assembled. But perhaps what I'll call the interface board was assembled by hand, and the assemblers were just too busy pushing these things on down the line to get the job done. This thing mentions that it was manufactured by Delco Electronics, gives a city name of Kokomo, Indiana, but I'd be very surprised if this was actually manufactured there. Just like the radios of the time, I would imagine that this was assembled in Mexico, although its place of assembly has no bearing whatsoever on the quality of the job. At least I don't believe so. So all of these resistors need to be soldered down to the board. And I'm probably going to go ahead and check the other components on this board just to make sure that they're all tightly in place. But let's go ahead and pop this board out, have a better look at it. The so-called interface board is held into its half of the plastic case by way of two clips. There's one here on the left-hand side, and then moving across the way there's also one on the right hand side. Now again, it pays to be very careful with these. I noticed that in the case of this particular assembly, the left hand side was compliant and free to be released, where the right hand side was extremely stiff. I had to play the circuit board back and forth with the minuscule degree of freedom that it happened to have before I was able to convince this latching clip to come undone. You don't want to get too rambunctious with these because you will break them. The moment I slid the circuit board out of the case, how miserable the state of affairs here became immediately obvious. This is an extremely bad situation here. You can see that these solder joints holding all of these resistors into place are an extremely unhealthy gray color. It looks like this one right here, I'll get something to point with here, didn't even get a visit from the soldering iron at the factory. And you can compare the unhealthy pasty gray color of these to the other solder joints on the board holding other components in place. They're nice and shiny, just as they should be. So were these bad from the get-go? Well, yes, I think that some of them were, and for those that weren't, well, I think it wasn't too long before the intense heat that's obviously emitted by these particular resistors did the remaining solder joints in. So it's time to go ahead and find my soldering equipment and see what I can do about this. I'm going to go ahead and clean up all of this old solder because I don't think it can possibly be reflowed. Try to clean up these through holes as much as I possibly can, and I'll see about putting these resistors back into place. And hopefully they will stay there for a good long time to come. But yeah, I really wonder whether or not this circuit board actually worked as it was supposed to when this car was new. I've gone ahead and resoldered almost all of the joints on this board that had failed after cleaning them up with my desoldering iron, but I went ahead and I left one of them undone because there was something interesting that I noticed that may complicate this repair if it ever has to be done again. And it's also an issue that you might run into if you happen to do this yourself. And I certainly hope that you're not so unfortunate as to have to do this yourself, but I can't imagine that any of these other boards are any more reliable than this one. Go ahead and take a close look at this particular solder joint right here, if the camcorder will let us see it in close enough detail without overshadowing it. What I'm trying to show you here is that the trace, the actual part of the circuit board that serves to connect the leg of this resistor to everything else in the circuit that it ultimately ends up going to, has started to lift here. It looks like this has happened for no other reason than simple heating. These resistors, as previously mentioned, obviously put out an absolutely obscene amount of heat. And if this copper trace was broken, the thing to do would be to simply run a wire from the leg of this resistor, follow the trace on the circuit board to whatever it ultimately goes to, and simply make a direct connection. But I don't think things have degraded to that point. A couple of these had demonstrated similar behavior before I even touched them with the soldering iron. So it's entirely possible that if I ever have to do this again, or that if you have to repair your own circuit board and you're using this video as kind of a how-to guide, which it certainly is intended to be, that you may have to make some repairs using point-to-point wiring. Fortunately, this is a, pretty simple, straightforward affair. It's a single-sided circuit board, so you don't have to worry about a trace going to connect to another on an inside layer that you can't possibly connect to, or possibly having to scrape off some of this solder mask material and attempt to solder a bridge wire, or a jumper wire is the more correct term, to the bare copper track on the circuit board. So I'm going to go ahead and make this last repair here. You can see right away that my solder joints, the ones that I just completed, are very nice and shiny, just like the other ones on the board. Not exactly as neat, because I don't proclaim to be the world's foremost expert on soldering things, but the job that I did is entirely adequate, and hopefully it will hold up for many years to come. When I get done with this, go ahead and throw everything back together, take this out into the car, and we'll have a little test drive in the name of science. Alright, I'm back. I went ahead and I made the final solder connection here. As you can see, I did decide to make a jumper because I just don't trust this trace. It was barely hanging on by a thread, and I expect that with all of the heat and thermal cycling, that it was definitely the right decision to just go ahead and circumvent the problem. So I followed the trace along the board here. You can see how it kind of wends its way down, and then it goes over this way to this connection that I ultimately made. And in case you're wondering what that is, well, once again, it's a twist tie. Hey, it's got a wire core and some outer insulation, and this is a pretty low voltage application, so it beat going downstairs to get the hookup wire because I am, as I have mentioned in the past, a professional lazy butt. So let's go ahead and throw this thing back together, put it in the car, and see if we get any 6-foot flames out of the deal. Hopefully not. And would you look at that, the weather's beautiful again. Tell you what, welcome to Illinois. If you don't like the weather, wait 15 minutes. Okay, here we go. I've gone ahead and plugged it in. Nothing blew up when I did. But here's the real test. Look at that, we've got ourselves a display. Alright, let's see if the climate controls generally do what they ought to do here. We'll try turning the system on. There's the blower fan coming up. Alright, let's try for airflow adjustments. Should be coming out the dash vents any moment now. That definitely looks to be happening. Doesn't seem that I can mess the display up. No, it's not 100 degrees out here. Alright, windshield, floor. I don't think it'll let me do anything other than that unless I hit defrost, and then it goes to the windshield. How about vent? It's not acknowledging the request for vent, probably because I've got to direct the airflow somewhere that it actually can vent. There we go. Recirculate. Go ahead and kick the fan up to maximum. Most of these functions are operated by pancake motors, so I think they'll work even though the engine isn't running. I'm not aware of anything in this car that depends upon the engine vacuum to actuate the climate control system. The rear defogger on this car has not worked in a long time, and I tested the defogger grid only to find that it seemed to be okay. There were no visible breaks in it, no breaks in continuity. I'm wondering if any of those resistors that I resoldered are responsible for directing power to the rear window defogger. I would not at all be surprised. I have not attempted to trace the circuit on this in any way, shape, or form. Maybe those of you who are more inclined to do so can pause the video where I was looking at the circuit traces, and if you have access to a General Motors factory service manual for this car, well, maybe you can determine that for yourself. Meanwhile, as much of a strain as I've put on this car's battery playing with the blower fan just now, I think it's time to go ahead and put this unit back into place, put this trim piece back on, hook all the wiring connectors back up, and go for a test drive in the name of science. A lot of science involved with this project. Not that that's a bad thing. No smoke, no burning, no obvious signs of defects, so apparently everything's good to go. So let's stick this thing back in the dash. Have you ever heard that saying, if everything seems to be going well, you've obviously overlooked something? I'm here to tell you it's true, folks. As I was working on putting this car's dashboard back together, I decided I needed to go in and get a few other things before I buttoned this all the way up and took the car for a test drive. Well, as I pulled the shifter down into first gear to assist with the removal of some of the dash trim and turned the key on, the car cycled its door locks. I didn't really pay attention to their state. Little did I know that when I shut the door on the car to go into the house, I'd locked the keys inside it. So I made a frantic dash around the house looking for the second set of keys, which I never did manage to find. And then I remembered there was a little something that the previous owners had left attached to this car. We discovered it quite by accident when we had it up in the air on a lift. That's right, a hidden key compartment. Today is my lucky day. So now I've got that little mess sorted out. I'm going to go ahead and put that thing back where it goes. This actually attaches to a metallic portion of the car's body via powerful magnets. And there's a spare duplicate of the keys in there, as you might imagine. So now, as I said, as I've got that little situation sorted out, let's go ahead and take this car for a test drive and see if the climate controls do what they ought to do. Phew. All right, it's time to see if I ran the car's battery down. I don't know how many years we've owned this car for absolutely certain, but I know I made a YouTube video about it back in the day. Still got the same battery that came in it when we bought it, and it's known not to be the strongest thing in the world. So let's see if it survived all of the gymnastics that it was exposed to just now. Oh no. I think we're skinned. Alright, now I'm apparently going to have to find some jumper cables. Like I said, if everything seems to be going well, you've obviously overlooked something. Alright, let's see if this exceptionally naughty Buick will start with a little bit of assistance. I may have to let it sit and cook for a bit. Either got a bad connection, or I'm just going to have to let it cook. Okay, incredibly naughty Buick start attempt number 2. You gotta love rusty, crusty old pairs of jumper cables. They make such exquisite electrical contact. I wouldn't say they're making enough contact yet, but we're gonna find out. Good enough. Good enough. Alright, after that lovely little sidebar, I think we're finally ready to go. Yeah, that battery's not in very good shape. You can see it's not really charging at all to speak of, despite the fact that mere moments ago it was too dead to even let most of the car's accessories operate correctly. And if I speed up the engine, the battery charging doesn't really pick up, so we know the alternator's not limited in terms of capacity. So let's go ahead and try the climate controls here. I've never been a fan of fully automated climate controls in a car, I have to admit. And right here is one of the key reasons why. Instead of letting the system go ahead and cool itself down and then gradually bringing the fan speed up, it just immediately hits the gas, winds the fan up as far as it'll go. And I gotta be careful about what I'm doing here because I got trash cans on that end. And I got the neighbor's daughter's idiot husband who has no concept of how to get the HE double hockey sticks off the road. Sorry. I've mentioned in the past that I am definitely a closet rager, even though I try to be a positive thinker and generally upbeat person. The other thing I don't like about these automatic climate control systems is the fact that when they reach their the alleged desired set point, they slow the fan down to nothing at all. And I don't know about you, but I like to keep the fan in a car kicked up a few notches, just so that the air will circulate and it doesn't get stale or anything like that. I'm gonna have to reset the clock. This thing lost all its memories. But at least that display looks to be doing really well. Temperature's coming down as we move out of the direct sunlight and more into the breeze. I've got a small bag of recycling, but I guess I'm gonna go ahead and take it, just to give this car some much needed driving. It hasn't been driven in almost a week now, which might explain the battery situation. See, there it is starting to ramp the fan down. I'm going to override that here in a little bit. I don't know if a person could get a Buick Park Avenue with manual climate controls. I suppose it was too much of a luxury car to hope for that option being available, or should I say standard equipment being available. But if it was, that's how I definitely would have taken it. Okay, well, we'll check in on this thing after I've done some driving, but I think the fix is effective, at least for now. At this particular juncture, I'm very happy with how this repair has turned out. However, before I go ahead and close up this video, there were just a few things that I wanted to make sure were working correctly, because happiness comes from getting the details right. And what's that out there above the hood? That looks like a head-up display. Yes, indeed, this car has one of those. It's very slick. Although in the manual they tell you not to use it as an estimate of how far away you are from something, because you will probably hit it. But getting back to the point here, everything seems to be working pretty well on this car. The climate control display has not faltered in approximately 1 hour's worth of driving over smooth and bumpy roads alike. So really there was only one question left to answer, and that was whether or not every last aspect of the climate control's operation was satisfactory. In particular, the backlighting and the panel dimmer. Well, I don't drive this car a lot, since this is my mother's car. Excuse me, had a frog in my throat there. As I started to say, I don't drive this car particularly often because it's my mother's car and I usually leave that task to her. So I don't know all of this car's little details. But one thing that I did notice about this car is that when you turn the headlights on manually, the panel dimmer does not affect everything in the dashboard equally. You can control the brightness of the instrument cluster, but the radio and the climate control do not respond to that unless the car's built-in ambient light sensor thinks it's dark enough. And at that point, then the panel dimmer adjustment affects everything equally. I'll go ahead and come to a stop up here at this intersection, and I'll go ahead and demonstrate exactly what I'm talking about. I had to wait until it got a little bit darker, so I passed the time by eating a little bit of pizza. You see there I turned the dimmer down. Now I'll go ahead, turn the dimmer up, and you can see that everything gets brighter. The radio indicators, the instrument panel, everything that you would expect. The only other problem is that we obviously have some burned out indicator lamps in the climate control panel. Now, if I was really feeling diligent, thorough, assiduous, or any of a number of choice of $5 words, I probably would have gone ahead and fixed that as well. Although that would have involved a lot more disassembly, and I'm not sure it really matters that much because the controls are laid out in a sensible enough fashion that once you've driven this car a couple of times, simple muscle memory takes over. A possibility for converting that to something, you could just replace them with incandescent lamps. That'd be the most straightforward thing to do, even though those grain of sand bulbs are kind of annoying to deal with and handle. But I would actually consider doing an LED retrofit. The only drawback is that you'd have to modify the circuit somewhere so that you could insert the needed series resistance so that any LEDs that you added would not enter a runaway condition and end up self-destructing. You would of course also have to figure the resistance, but it should be easy enough to get into the ballpark if you decide to do something like that, even with the panel dimmer varying the amount of voltage that ends up flowing through the lighting circuit. So yeah, I'm basically happy with this at this point. Everything seems to be working pretty well. We've got the display back. It seems reliable. The dimming's working. So I certainly hope that you have enjoyed watching this video as much as I did making it. If you have a car with this problem, I hope that you have found this video informative and that it will aid greatly in your troubleshooting. And as always, I encourage you to leave a comment if you happen to have one.